Algebra 1, Lesson 53. We are adding and subtracting polynomials. We have a lot of vocabulary terms in this one. First, let's go over these. So monomial, we are talking about the product of numbers and variables with whole number exponents. Degree of monomials, this is the sum of the exponents of the variables in the monomial. And our coefficients, or here called constants, has a degree of 0. Degree of a polynomial, this is the greatest degree term. So if we're looking at a list and a term has a degree of 3, and that's the biggest one, that is the degree of the polynomial. Leading coefficient is when we order them in standard form, that is the coefficient of the greatest degree term. And standard form, we are ordering them from degree greatest to least. So monomial, we have 1 term. Binomial, 2 terms. And trinomial, 3 terms. Now remember, remember that terms are separated by addition and subtraction. Okay, so here are some examples. We could say we have a monomial, monomial, monomial. Remember, division doesn't separate terms. We have a binomial, a monomial, monomial. All of these are monomials, except for this is a binomial and this is a trinomial. We have monomials all the way around. Now, we need to decide what is the degree of a monomial. When we find the degree of the monomial, we need to add up all of the exponents of each variable. The coefficients don't matter, okay? We don't add those into the degree. So in this case, we look at the variables and say this is x squared and y squared, so we're going to add together 2 and 2 to get a degree of 4. If we don't see an exponent, we can assume, well, we know actually, that exponent is 1, which means we can add up 1 plus 2 plus 1, so we get a degree of 4. Again, we have a to the first, b to the third, c to the first, so 1 plus 3 plus 1 is 5. Now, a little trickier, this 35 to the 4th, although we see an exponent, it's on a coefficient, which we don't include into our degree. But we do include a to the first, b to the first, and c to the 5th to get a degree of 7. And lastly, we have 1, 3, and 2 added together to get 6. Okay, now we use this because we use it to order our polynomials in standard form. So we go based on the degree of the monomial, okay, the degree of the term in order from greatest to least. So in our first case here, we would say this is a degree of 3, degree of 2, degree of 1, degree of 0. So we order those greatest to least like we have them. And then we say, what is the leading coefficient? Which means of this term that has the greatest degree, our leading coefficient is 8. So looking at some other examples, 2n squared plus n cubed, well, n cubed actually has the greater degree, so we would put it first. And the leading coefficient on that, well, we're looking at this term and saying, what is its coefficient? Well, actually it's multiplied by 1, so the leading coefficient is 1. Next, let's go and figure out the degrees of each of these. Well, 8xy squared has a degree of 3. Negative 9 has a degree of 0. 5x cubed y cubed z has a degree of 7. So we're going to order it and say 5x cubed y cubed z plus 8xy squared minus 9. And then we say the leading coefficient is based on that, so the leading coefficient is 5. Okay. Now let me find a couple more practices of like we just did. So we need to order these in standard form and find the leading coefficient. So we're going to order them and say this has a degree of 3, a degree of 1, 2, and 0. So we say 7x cubed plus 5x squared minus x plus 8, which means the leading coefficient is right here, 7. Next one, I'll just show all of these. I'll do just a couple of these and you can try the rest. This one has a degree of 3, a degree of 4, degree of 0, degree of 2. So we're going to say we have negative 2b to the 4th plus 3a squared b minus 6ab plus 5, which means our leading coefficient is based on this term, and we have negative 2 as the leading coefficient. And I'll do the last one on this page. We have a degree of 3, 4, and 2, so we say we have negative 3x squared y squared plus 9x squared y minus 5xy. Our leading coefficient right there is negative 3. Okay. Let's now talk about how we add and subtract our polynomials. Now, a lot of times you'll see them like this in a couple different groups, and we're either adding or subtracting between them. In this case, since we're adding, we can go ahead and just add all of these different things, because that addition, even if we distribute it, it's not going to change anything. So we can just combine like terms. So there's a couple ways to do this. The first way is to lump together all of the like terms, so x squared and 2x squared. We can put those together using the commutative property to move them. We can move 3x and negative x together, and negative 3 and 2 together, so that we can combine them to say 1x squared plus 2x squared is 3x squared. We get 2x minus 1. Now there's another way that I want to show you, and that's almost like an addition, working it down kind of method. So we have x squared plus 3x minus 3. This really only works if you've put them in standard form. And we have 2x squared minus x plus 2. So we put them on top of each other, and we can add them. So that we get, well, minus 3 plus 2 is a negative 1. 3x minus x is a 2x, a positive 2x, and we have 3x squared. So we get the same answer, just a different method. So in these cases, I'll show you both of the methods. The first one, I'll just combine. I'll move together the like terms. So we have 3x squared plus x squared. We have a 2x and a negative 6x. And then we have negative 4 plus 7. So we can combine to get negative 2x squared. We combine to get a negative 4x and a positive 3. All right. And then we could also do the adding down method with these couple groups. So I'm going to put these in standard form to say we have negative x squared plus 3x plus 6 on top of 2x squared plus 5x minus 8. Really, I'm just putting them next to their like terms so that we can say we have negative 2, we have a positive 8x, and we have plus x squared. You don't need to show that plus right there. Okay? Always want to leave it so that we have standard form at the end. Now, this method really works well if we have addition between our parentheses. But if we don't, if we have subtraction, we need to do a couple things before we get there. What this subtraction means is that everything in this parentheses needs to be subtracted. So I need to distribute this subtraction to everything inside. So that we get 6x squared plus 4x plus 2 minus 2x, so a negative 2x, now a positive x, and minus 8. And regardless of what method you use, either the move them to be near their like terms or putting them one on top of each other, you should get 4x squared plus 5x minus 6. So we'll just do a couple more examples of these. Okay, I'll do the bottom one. It looks a little bit more difficult. So I'm going to distribute the negative sign to 4 terms inside. And I'm going to order and say we have negative 7m cubed plus m squared minus m minus 3. And then I have my negative 10m cubed. I have my minus m now, once I distribute the negative sign. I have a minus 2, and now a negative m squared is a positive m squared. And now I can add these up. A lot harder to try to subtract with this method, but once you distribute that subtraction, I can just add them up and get a negative 5, a negative 2m, plus 2m squared and a negative 17m cubed. Let me just look at a couple more examples that I want to try. Okay, let's look at this one. For the years 1995 through 2001, the number of websites for the businesses and education can be represented by these expressions. Write an expression for the total number of websites, meaning we need to add these up. And thankfully, they are actually already in standard form, so I can just add the different parts. So I'm going to add 0.607 plus 0.296, which gives me 0.903, and then I have a negative 1.035t plus a negative 0.121, meaning I can just add the numbers and then realize that it is negative, and I get negative 1.156 t plus this 0.903, and then I'm going to add my t squareds to get 0.333 plus 0.098, and so I get 0.431 t squared. Okay, and that would be the total number of websites. All right, let's try a couple more examples. Okay, now I'll do this one. Realize that even if we're not, we care about that we have like terms. So A's need to go with A's, B's with B's, C's with C's. So I have a 2A and a 3A, meaning I have a 5A. I have a 3B, a negative 5B. Okay, so be careful. So a 3b minus 5b is a negative 2b. I have a positive 2c because I'm subtracting a negative, and I have a negative 7c, which means I have a negative 5c. So be very careful expanding so that you know what you are subtracting, what you are adding. So I'll try it again a different way this time, let's say. I'm going to expand first for all of these, and so I now have 8a plus 5b minus 3b plus 2a, double negative, minus 3a minus 5b. And I'll move these to be near each other, so I'll move the 8a plus 2a and minus 3a. There we go. We have all of my a's represented now. And then plus 5b minus 3b minus 5b. So the a's, well, 8a plus 2a minus 3a is 7a, and 5b minus 5b, those actually cancel each other out, and we're left with minus 3b. And that's my answer. Okay. All right, I'll leave you for these next examples. Just realize if we're thinking about perimeter, if we are given the perimeter, we're going to say 8m minus 11n is going to equal, well, the length is, the length of each of the two congruent sides is 3m minus 8n, meaning I have two of those, plus a certain amount, 2 of a certain other amount, and I'm going to call that x. And I'll work this one out actually and say we have 8m minus 11n is equal to 6m minus 16n plus 2x. And if I want to know what x is, because I want to know the length of the, or sorry, this is a triangle, so we have just one of these x's. We don't have two of them, just one. I'm going to subtract 6m from each side because I want to get x alone, and I'm also going to add 16n to each side, which means we get x by itself because these cancel out, and we end up with 5n and 2m, which means 2m plus 5n is of that last side of the triangle. Here's one more example that you can try. And I hope this is helpful for your homework and for studying.